Hi, my name is Juliette Baines, and I'm a junior paper conservator at the Rijksmuseum, and I'm here today with Gauthier Patin, who you've heard of earlier already, and he is a researcher at the Dutch Cultural Heritage Agency. And it's a real pleasure to share our research findings on light-induced fading in Japanese woodblock prints with all of you here today. The Rijksmuseum holds around 1 million objects, including over 5,000 Japanese prints, albums, and illustrated books. The majority come from the Edo period, which you've heard earlier spans from 1603 to 1868. The museum regularly showcases Japanese prints in both small and large temporary exhibitions, and I'm showing you here a picture taken during one of those exhibitions in the 1970s. The Rijksmuseum also frequently loans works to other museums, and there's a study room where visitors can request objects to see them in person. The collection includes works by renowned Edo period artists, such as Utamaro, Hokusai, and Hiroshige. Some of them are longtime visitor favorites, and I'm sure you can guess which one that is. Many were acquired through donations and purchases since the early 20th century. Since 2012, there's a dedicated curator of Japanese prints, Marie Janse, and she has led exhibitions and acquisitions. And I'm showing a recent acquisition here, which is the Poppies, also by Hokusai, that was purchased in 2023. The collection also continues to grow through donations from collectors, mostly from the Netherlands. But as exciting as all of this is, the fragile nature of Japanese prints, especially their light-sensitive organic colorants, limits how and when they can be displayed. Light-induced fading is a well-known issue. A good example I'm showing here is by Toyokoni, and only some faded colors remain at the edges. But if we compare it to a print of the same print, a different version, at the Museum of Fine Arts in Boston, we see a distinct difference in color. This comparison highlights what can be lost over time in a very dramatic fashion. The print at the Rijksmuseum we own, and it arrived discolored like this, I would like to assure you. It got discolored because it was owned by George Hendrik Breitner. He's a Dutch Impressionist painter. And the print serves as a physical reminder of the influence Japanese prints had on European artists in the 19th century. And we can imagine this artist enjoying the print, inadvertently damaging it. And today, we still like to enjoy these prints. But the combination of the fragile colorants there presents us with a dilemma. And we ask ourselves the question of how can we provide access through display while managing their long-term preservation. General lighting guidelines are in place at the Rijksmuseum. Works on paper are shown for no more than 1 year per decade and are strict lighting conditions of 50 lux and no UV. And only since 2001, exhibition history is documented. Earlier records are unfortunately inconsistent, and pre-acquisition display by previous owners. I'm showing you one here, an unknown lady sitting in front of Japanese prints. It's part of our photo collection. But it shows that these prints have a life before they enter our collection. In recent years, microfading has been introduced, though only selectively, on individual works of art on paper. Microfading, also short MFT, it serves as a more objective tool to help make display decisions. Individual testing is possible if there are serious doubts on the light stableness of a drawing or print, but becomes harder to realize when you're dealing with a larger collection. I would like to remind you we're dealing with 5,000 prints here. Knowing the light stableness of objects has become especially relevant at the museum as it reassesses its permanent exhibition. At the museum, paper artworks have been rotated in designated low-light areas, but curators now want to integrate prints and drawings alongside less light-sensitive objects. In this context, conservators play a key role in offering data-driven advice, with microfading providing a promising way to predict sensitivity. It allows for the assessment of color stability on individual objects and enables more tailored light exposure guidelines, potentially for larger groups within the prints and drawings collection. To better understand and safeguard our Edo period prints, we launched a dedicated research initiative in 2024 called Japanese Prints: A Closer Look. This project was made possible through the support of Metamorphose, the Dutch national program for the preservation of paper heritage. The project is a multidisciplinary effort bringing together curators, conservators, and scientists. And furthermore, parts of the project are carried out in collaboration with the Cultural Heritage Agency of the Netherlands, the RCE. And within the larger project, we also had a chance to work together with the University of Amsterdam. Emily, thank you for your presentation earlier, and the Museum of Fine Arts in Boston. Early on in the project, we reached out to our colleagues at the Museum of Fine Arts in Boston, where they, over the past 20 years, Michiko Adachi and her predecessor Michelle Derrick have conducted research on pigments and colorants in Edo period prints. The Boston conservators created a sample set by sourcing traditional materials from Japan, recreating pigments and colorants, and printing them on Japanese paper. They generously shared parts of their sample set with us, giving us a crucial head start. The project Japanese Prints: A Closer Look has two main goals: to analyze the materials used in Edo period prints. I'm showing you here an example of how, through technical photography, we can identify, for instance, indigo. In the print that I also showed you earlier of the poppies, we used infrared, false color infrared and UV. And as you can see, if we have our color sample set, we can identify indigo that reacts the same under these conditions. Secondly, the project studies how these materials age, especially their sensitivity to light. We exposed the samples to controlled light aging tests using xenotesting and microfading. And today, Gauthier and I will focus on the second part. While many important studies have focused on identifying the colorants used in Japanese prints, relatively few have explored how stable these traditional colorants are by means of accelerated aging testing. We see that in the 80s, the first studies into the light sensitivity of colors in Japanese prints were conducted by Hiraoka, and he artificially aged samples of paper dyed with yellow, plant-based dyes. Feller expanded on this work by testing a wide range of organic colorants, and his findings showed that some colorants, like dayflower blue and softflower, were extremely light sensitive. Over 2 decades later, in 2005, Connors introduced a new approach by using microfading. And he used them on original Japanese prints. The study results showed that yellow was the most fugitive. In parallel, Sasaki and Coombs also carried out light aging tests and MFT tests, focusing specifically on the 3 main blue pigments that are found in Japanese prints: the earlier mentioned dayflower blue, the indigo that I just also showed earlier, and Prussian blue. Interestingly, their findings suggested that dayflower blue was more stable than previously thought. And in this slide, I have highlighted the current study that we are now, and an earlier study of the early 2000s. And this is when the RCE, the Dutch Cultural Heritage Agency, where Gauthier works, got first involved. And this is also the point where I'll hand things over to Gauthier.
Oops, sorry. Okay, I'm now going to present you 2 research projects on Japanese prints that have been conducted at the Cultural Heritage Agency of the Netherlands. One was in 2008, and the other one was in 2024. The 2008 project was a collaboration with the Waterland Museum in Leiden and led to the publication of an article in Studies in Conservation. The project had a retrospective approach, meaning that color measurements were performed on objects while being exposed in the gallery, and this for a period of 1 year. In addition, the influence of color change perception on the values of the object was also studied. At an overview of the result, it has been shown that after a year of exposure, most color presented a color change smaller than a just noticeable change, except for the blue. In addition, it has also been shown that the visual complexity of works of art hinders the perception of color change. So all in all, those results prompt the museums to limit the exposure of the print. However, in practice, it proved difficult to implement. The second project was initiated by the Rijksmuseum Amsterdam and was described by Juliet earlier. It had a prognosis approach, meaning that light aging tests were performed prior any exhibition of the real object. As Juliet mentioned, two types of tests have been performed on the sample. First, we put them in the xenotest chamber, and you can see on the right some of the sample in a metal holder that then goes into the chamber. And then we also performed microfading analysis. In both cases, we use blue wool standards to assess the light fastness of our sample. And here are some of the results for sample. And what we've done is, like for each sample, we cut a strip and we divided the sample into small sections. And we exposed the section at a different period. And for us, it was really important to have this visual aspect of color change. And for some of them, such as the flower and safflower, we can clearly see the gradation. Sorry, I'm talking too much. We can clearly see the color change and its gradation. And now, here are the microfading graph for the same sample. I'm not going to focus too much on this one, but these types of graphs enable us to compare our result with the sample. But what we can do first is actually change the x-axis to a scale that is much more familiar to us, such as exhibition time. And then since we want to do some prognosis, we can extrapolate the curve so that it enables us to do some prognosis over longer periods of time. But at the end of the day, and that's what's really interesting us, is that we want to translate those numerical data. It's good for scientists to play around, but not really for us. We want to have some more visualization of what's happening. So for example, here I took a sample, safflower. I asked the initial color of the sample prior any exposure, and then we can ask to retrieve the color according to the exposure period, and that's what I've been asked at 5, 10, and 75. And this is the kind of result that we can obtain. And this is, for us, this is much more, it's easier to communicate this kind of result with a broader audience, and then to start a discussion of, okay, what do we accept as color change, for example. And here is also just an overview of the light fastness of those four samples, where I'm showing you the blue wool standard equivalency. It's just to show you that basically most of the sample presented had a light fastness between blue wool 2 and blue wool 4. We also saw a good correlation between the xenotest and the MFT in terms of blue wool standard equivalency value. But for me, the most important is that the combination of the xenotest and the MFT is that basically we were able to perform microfading analysis on artificially aged sample with the xenotest. Because indeed, in our collection, we barely don't have any pristine object. Most of them, as Juliet mentioned, they have been exposed. We don't know what's happened. So it was important for us to have this microfading on a xenotested object. And we can see that as a general trend, the light sensitivity of object decrease as they age. So now let's try to have a synthesis of those two projects in the light of the conference. First, we can see that both of them made use of the same theoretical framework, such as lighting budget, just noticeable change, color change acceptance, and so on. However, it was still difficult to really compare those two projects. First of all, because they had different research methodology. One was more retrospective, the other one was more predictive. And then also difficulty in accessing the data really hinders a good comparison of those two projects. Nevertheless, we could still observe a continuous evolution towards management of change, which is being fostered with more accurate prognostic as the technology evolves. So at the end of the day, what did we learn? What are the lessons? First of all, when we studied light aging, we realized the importance of having a data set that is representative of your collection. So I'm probably do not have to convince you, but all those reconstruction recipes, for us, they were really a key component of our research. Then we also saw that the technology evolved quicker than the theory. And for researchers, it's important to follow the new trends of the new technology, but it's also really challenging to that. It takes some time. And then the last thing that, as a lesson, is like the publication of the data. That's also a very important element. I know that earlier it was really difficult, but with the improvement of IT methods, it becomes easier to publish your data, or at least the most important data. I'm going to give back the floor to...
Thank you, Gauthier, for talking us through this. And I hope everybody's noticing we're dressed up as our samples. We have Dayflower Blue and Safflower Red, accidentally, but that's how organized we are and how invested. I would like to turn to the conclusions and the implications for the museum after going through the research results. To put it simply, the Japanese prints remain amongst the most light-sensitive objects in our collection. But with the outcomes of this research project, we can better manage the tension between wanting to show these works and the need to preserve them for the future. The study represents an important first step in advancing the Rijksmuseum's approach to assessing and managing the light sensitivity of Japanese woodblock prints from the Edo period. By systematically comparing light aging tests and reference samples, we have shown that xenon testing and microfading are complementary methods that together provide a deeper understanding of how traditional Japanese colors respond to light. Unlike earlier studies, which relied mainly on theoretical projections or documenting damage after it occurred, this research allows us to predict color change in advance. The combination of xenon and microfading testing enables us to identify vulnerabilities within the collection, giving us valuable insights into which colorants are most sensitive. What that exactly means for the current light policy of the museum regarding the Japanese prints collection remains a point to be evaluated and decided in discussion between curators, conservators, and scientists. By visualizing color change, we can give all stakeholders clear and more accurate advice on display decisions. What stands out is that the color analysis is essential. By knowing which pigments are present, we can anticipate potential discoloration without having to apply microfading tests on every single print. The image on the right let me see. And I've added a picture of a more recent exhibition, 2016, where we were showing modern Japanese prints. And that is also a fitting bridge to what lies ahead of us in our research. Because in 2022, the Rijksmuseum's collection was enriched by a major donation of more than 1,100 Japanese prints and illustrated books from the first half of the 20th century. This means we have a wish for our research to expand beyond Edo period prints into the modern era, where new pigments and colorants require fresh analysis and new reference samples. We would like to thank the Metamorphose organization for their generous support. And our sincere gratitude also go out to the curators and conservators of the Boston Museum of Fine Arts, the Wereldmuseum in Leiden, and the Royal Museum of Art and History here in Belgium, in Brussels. They shared very freely their knowledge with us, so we're very thankful to them. And finally, Gauthier and I wish to acknowledge our dear colleagues from both our institutions with whom it has been a pleasure to work with, and of course the IADA organization for letting us share our research today.